Welcome to the House of Maths. Today we're going to learn about finding exact trig values for sine, cosine and tangent. Now in order to get this going, you're going to need to know what these curves look like. Okay, so let's start with the sine curve, and this looks like this. So as you can see with the sine curve, it starts at 0. Reaches a high point at 90 degrees, comes down through 180, so 0 there, low point at 270, and back to 0 at 360. So this high point here is going to occur at 1, and this low point here will occur at -1. So if we want the exact values of sine, we can find them like this. So sine 0 degrees, which is here, on this axis, is going to give us 0. Sine 90 degrees, here's 90, and it's at a maximum, so it will equal 1. At 180, it's 0. At 270, it's -1. But these two are the most common ones. So for sine 0 degrees equals 0, sine 90 degrees equals 1. Now let's have a look at the cosine curve. So what does the cosine curve look like? This one looks like this. Okay, cosine curve goes like that. So it's at a maximum here, 0 degrees. It's at a minimum 180 here, and a maximum at 360 when it's completed one revolution. So we can say, sorry, don't want to say that because we're looking at the cosine curve. So cosine 0 degrees equals 1. Cosine 90 degrees, which is here, equals 0. So they're the most common ones that you're going to get. So that's sine and cosine. Let's have a look at the next one, which is tangent. So what does a tangent curve look like? This one looks like this. Okay. There's the tangent curve, and we've got at 90 degrees we have what we call an asymptote. So the curve, tangent curve, never actually touches the asymptote, which is at 90 degrees, and up here it never actually touches the asymptote. So what have we got going on here then? So tangent 0 degrees, which is here, is 0, and tan 90 degrees, which is here, right on this asymptote. You're not going to get a value for tangent, so we say it's undefined. If you type into your calculator tan 90 degrees, you'll get error or undefined. So there's no value there. What you will spot though is that somewhere on this tangent curve we're going to have a value of 1. I've not drawn mine fantastically accurately, but there's 1. So it would give a value somewhere along here, and we can find that. I'll show you that in a very short while. So those are what the three curves look like. You need to know those, and you need to know the values of basically 0 and 1 on each of those. So what about values that are in between? How do we find those? So what I'm going to look at finding are these values. It is possible to find the values of 30 degrees, 45 degrees, and 60 degrees. These ones are quite common and they come up quite frequently on the GCSE papers. So how do we do this? Okay, let's take a triangle like so. Here I've drawn an equilateral triangle. So with an equilateral triangle, we know that the sides are all the same length. So I'm going to call these lengths 2. Okay, you'll see why I've not put 2 at the bottom in a sec. Now the angles on an equilateral triangle are also all the same, and they are 60 degrees. So I'm going to put 60 in here, and I'm going to put 60 degrees in here. We know that's right because those are the features of an equilateral triangle. Then I'm going to drop a perpendicular from the centre all the way down there. So this splits the base exactly in half. So this length has got to be 1, this length has got to be 1. And we're going to get a right angle triangle here at the bottom. A right angle, which is going to give us a right angle triangle here and another one here. So we've got these 2 base angles the same. Now at the top, because this perpendicular has split this in half, that angle there will be 30 degrees and that angle there will be 30 degrees. So where I said we were going to look for these angles at the top, we can certainly find these 2. Now we are missing this length in the middle here, but because we've got a right angle triangle here, we can use Pythagoras to find that. So we're looking for this length here. This is the longer length. So with Pythagoras, we get a squared plus b squared equals c squared. So in this case here, if we call this one a, this one b, and this one c, we're going to get 1 squared plus b squared equals 2 squared. So rearranging that to find b, we're going to get b equals 2 squared minus 1 squared rooted. So that's going to be 4, take 1, take 1. So b is going to equal root 3. So this length here is root 3. Now we can use this to find these 2. So let's have a look. What's cos 30? So we've got a 30 up here. We're going to use this. Cosine of this, so that's adjacent over hypotenuse. So that is root 3 over 2. What about sine 30? So we'll stick with this. Sine 30 is opposite over hypotenuse. So that's 1 over 2. So look at the cosine now. Cosine 60. So we've got a 60 here. So that's adjacent over hypotenuse. And sine 60. So 60 here. So opposite over hypotenuse. So look at the tangent. So we can do tan 30. What's tan 30? Opposite over adjacent. So that's 1 over root 3. And then we can do tan 60. 60 here. So that is opposite over adjacent. So that's just going to be root 3. So using that triangle, the equilateral triangle, we can find sine, cos and tan of 30 and 60. But that leaves us 45. How do we do that? Now this time I'm going to draw a right angle triangle. like so. And I'm going to make the two side lengths, the shorter lengths if you like, the same length. I'm going to make them 1 unit. Now doing that, making these lengths the same, will give me 45 degrees there and there. So we need to find the longer length this time, and we're going to use Pythagoras again to do that. So remember, a squared plus b squared equals c squared. Where c squared is the longer side, so we're going to get 1 squared plus 1 squared equals c squared. So c is going to equal that. So that's going to be root 2. So this length is root 2. Okay, so we're going to now find cos 45 degrees. Well, here's 45 degrees. The cosine is the adjacent over the hypotenuse. So 1 over root 2. Sine 45, again 45 here, opposite over hypotenuse. And tan 45, 45 here, opposite over adjacent. It's 1 over 1, which is just 1. So we've got cos, sine and tan 45 degrees, the exact value. So those are the most common ones. Obviously you can learn them off by heart if you want, but if you use the method that I've shown you here, you've got a way of working it out, which is probably the better way to do it rather than trying to commit everything to memory. Well, there you go. Thank you very much.